away with for the most part, but you want to look at that and know that that means 2x minus 5 times x minus 3. That is a multiplication expression. We're multiplying those two sets of brackets together. So that's a multiplication statement, and then this is a multiplication statement. Okay, x plus 4 times 5x minus 1. So what you have to do is you have to do those multiplication statements before you do any adding or subtracting, because that's how BEDMAS works. Okay, so you need to use your multiplication before addition or subtraction. So here, what you would do is you would multiply out both of these sets of multiplications. So I go 2x times x, which is 2x squared, 2x times negative 3, which is negative 6x, negative 5 times x is negative 5x, and negative 5 times negative 3 is positive 15. Okay, and see, I just put brackets around it because it's my answer. Okay, it's my answer to that multiplication. I put just kind of in brackets. And then I do the same thing with the next set. So I go plus, and I do the same thing with this set. So it's 5x squared minus x plus 20x minus 4. Okay? So I have all this. Now it's up to you at this point. You can either, in each individual one, take a minute and put these together. So put those two together and those two together. You can do that. So if you did that, you would get 2x squared minus 11x plus 15 plus 5x squared plus 19x minus 4. Okay, you can do that. You don't have to do that at this point if you don't want to. You could just leave them out long and do your entire simplification process at once, and you'll see what I mean in a minute. So once you have these two sets that are completely finished, you're just combining like terms. Okay, so we have 2x squared and we have 5x squared. And they're adding because there's a plus sign in between them. So if we're adding, that's 7x squared. Okay, because we put 2x squared and 5x squared and we add them together since it's adding between here. Okay, then I have negative 11 and positive 19 x's. So what would that make? 8. So it's plus 8x. And then I have 15 ones and negative 4 ones. So together that makes 11. Okay, and so there we go. That long top expression simplifies down to 7x squared plus 8x plus 11. That's it. Okay, that's it. So these are equivalent expressions. Okay, that means that when I say equivalent expressions, what that means is if I filled a value in for x at the beginning. So if I just picked a number for x and filled it in, and then I picked the same number for x at the end and filled it in, I would get the same value. Okay, so that is a possible way to check your work, and you can do it quite quickly on a calculator, especially if you have a like TI-84 or something like that. You could check it quite quickly. So if I wanted to do that, okay, I could pick any value of x that I wanted. Okay, so I could say I'm just going to let x equal 3. Or, you know what, 0. Okay, any value. You wouldn't want to pick something high like 20. That would make the numbers really high. But if I pick something like x equals 2, let's say, that's pretty low, okay, and I plug that number in to this top expression. So I did 2x minus 5, x minus 3. I'm going to just show you what I mean by this, because some students really don't understand this when I say plug in. It is something you've done before, but some students have a little bit of trouble with it. So if I was substituting the value 2 in for x, what that would mean is that everywhere I see an x, I'm thinking it's a 2. So instead of 2x, which means 2 times x, I would do 2 times 2. And I would never write this down if I was doing it myself. And instead of x minus 3, I do 2 minus 3. Plus, and then instead of x plus 4, I do 2 plus 4. And instead of 5x, I do 5 times 2 minus 1. Now, I would usually not write that down. I would either be typing it into my calculator or I would be doing it kind of in my head. So when I say in my head, I don't mean doing that whole thing in my head because that would be kind of crazy. But I would do each set of brackets kind of in my head. So I'd be like doing 2 times 2 is 4 minus 5. So 4 minus 5 is negative 1. Okay? That's what I would be doing in my head. 2 minus 3 is also negative 1. plus 2 plus 4 is 6. And 5 times 2 is 10, minus 1 is 9. So that's 1 plus 54, which is 55. Now, if I do the exact same thing, but I do it with this final expression, 7x squared plus, and you can just do that on a calculator, right? And get that number right away. If I did it with this number here, so I did 7 times 2 squared plus 8 times 2, and 2 is just a randomly chosen number. I could pick any number. The easiest number to pick is probably 0, to be honest with you, because 0 would make everything really low. So here this is 7 times 2 squared, which is 4. 2 squared is 4, so that's 7 times 4, which is 28. 8 times 2 is 16, and 11. And if I add those up, okay, I get 34, 44, 45, 55. So it works as I hoped it would. That would be checking, but I wouldn't do all those steps. I would probably just type it into my calculator, right? Okay, like I wouldn't write anything down, probably, if I was doing this myself. I would just type that long thing into my calculator. But I'm showing you what you would type into your calculator, because what I found is that most students don't understand how to check their work, and they don't do it. Okay, if we're writing down equivalent expressions, you should be checking your work. Okay, and if on a multiple choice question, if you can't do the question, and you're given a situation where there's a long expansion to do, one thing you can always do is substitute any number in for x and check which of the answers matches. That's something you can do all the way up to grade 12 in questions that are just looking for equivalent expressions. Okay, because a lot of the time that's what math is about. It's finding something that's actually the same. Okay, and this is a way to check it very easily. I know it looks like a lot of writing, but I wouldn't actually write that down. That's just numbers. That's just something I type into my calculator. But you need to know how to do it, because students don't know how to do it. They don't know how to substitute something into x. Okay, and it's a really important basic skill. Okay, so you should be able to do something like that. Now this one, like I said, is a simple one. Okay, we're going to be seeing harder ones. I'm going to show you a subtraction here, and maybe one that's just slightly harder. So if we had something like 3a minus 5 squared minus 4 times 2a plus 1 times a minus 1.
That's supposed to be simpler than the first one we just did?
No, I said it's going to be harder. Why would I do a simpler one?
I thought you told me it was going to be simpler. I was like, okay.
No, we're going to be working harder. Okay, so here we have an expression that's a little bit harder. It's a little bit harder for 2 reasons. Actually, 3 reasons, I guess. First of all, there's a squared. That makes it a little bit harder because you have to know what to do with that. The fact that it's a subtraction is also harder. People tend to mess up the subtractions. And there are 3 things being multiplied in the second term. So here we have 4 times 2a plus 1 times a minus 1. And that's harder because there's 3 things. I see a lot of students when they get to something like that make mistakes. Okay, so watch me do. I suggest writing this down. This is definitely going to be something you have to do, and it's a little bit long. Okay, so first of all, when you see something like 3a minus 5 squared, okay, what does that mean? What does squared mean?
Multiplied by itself.
Multiplied by itself. What I see all the way up until grade 12, even my calculus students, I just actually corrected a calculus student on Thursday for doing this. They see 3a minus 5 squared, and they write 9a squared minus 25. And they just write that. No, you can't do that, but they do it anyway. Okay, so you can't do that. That's not what squared means. Okay, squared means multiplied by itself. So as soon as you see 3a minus 5 squared, you have to write 3a minus 5 times 3a minus 5. Okay, so that's the first step here, is noticing that and remembering that you're not allowed to just square both numbers inside. People really, really want to, but they're not allowed. Now, once you get here, there's this 4 out front. People really want to be able to multiply out that entire thing at once, the 4 times 2a plus 1 times a minus 1. You cannot multiply that out all at once. There's no way to do it in one step. You have to do it in 2 steps. Okay, so don't try to do it all in one step. I can't do it all in one step, so I don't think you can do it all in one step. Okay, so you need to multiply out your expressions first. So the first thing you would do here is do the 3a minus 5 times 3a minus 5. Okay, so do that. So you get 9a squared minus 15a minus 15a plus 25. Okay, that's what you should get. So again, Winston, even though we wrote it down, was going to write down 9a squared minus 25 or plus 25 or something. Okay, that would be incorrect. You still need to do all 4 multiplications. Okay, then here on the other side, you kind of ignore the 4. So you still write minus 4, and you have your bracket, because the multiplication you're going to do is with these things. Okay, so I get 2a squared minus 2a plus a minus 1. Okay, so you cannot, there's no way, like trust me on this, there's no combination of arrows that you can draw that include the 4 that would make this one step. Okay, you have to do it like this, where you multiply those two things together and then multiply the 4 through afterwards. Okay, so now we have this situation. Now I could simplify it a little bit, so I could put the ones in the middle together, just like I did last time. I actually do like doing that step. It is possible to do it without it, but I just think it simplifies things a little bit and makes things look nicer. So I get 9a squared minus 30a plus 25 minus 4 times 2a squared minus a minus 1. Okay, that's what I get there. So now, and this is really, really important with subtraction in particular, even if there wasn't a 4 there, there is, but even if there wasn't, yeah.
How did you go from negative 2a plus a? How does that equal just a?
Because I had negative 2, and I added 1 to it. So if you have negative 2 and you add 1, you get to negative 1. So that's what negative a means. Okay, that's a good question. Okay, so here, if you didn't have your 4, okay, if the 4 wasn't there, you'd still have to think about this minus sign. This subtraction sign applies to everything inside those brackets. That's really important. That means that that minus sign makes this minus 2 plus a plus 1. Because if you're subtracting a negative, it's like adding. Okay, so it's really important to remember that. But when there's a number out front, it's actually easier, I think. Yeah, because you're going to multiply this through to all of these. Okay, that 4 multiplies by all the stuff inside.
Now we work with the 4.
Yeah, at the end you work with the 4 here. So we have minus 8a squared plus 4a plus 4. So it's not until kind of the end, once you've expanded out all the different expressions, that you can function with the number that's out front. Now we just look for like terms. So I have 9a squared and negative 8a squared. So that makes a squared. I have negative 30 and positive 4, which makes negative 26. And I have 25 and 4. Gotta go? Okay. Which makes 29. Okay, and so there we go. That is our final answer. It simplifies quite nicely. And again, I could really quickly type that into a calculator just with some value in for a, or even easier than that, what if I plugged in 0 for a? Okay, if I just picked 0, what's 0 squared? Not 1. It's 0. Okay, what's 26 times 0? 0. So if I plugged in 0, it would just be 29. Okay, I can see really quickly that if I plugged in 0, it would just be 29. Then if I go up to the very top and I plug in 0 there, and if I just do it in my head even, that would be 0 minus 5. Girls, can you be quiet? 0 minus 5 is negative 5. Negative 5 squared is negative 5 times negative 5, which means 25. That would be 25 minus 4 times, if I put 0 in there, it would be 1 and negative 1, which is negative 1. And I can see that's 29. Okay, that would take me all of, I mean, I'm pretty good at mental math, but it would take me all of 20 seconds. Okay, so I would know that we're right. She just left. Yeah. Okay, so this one's significantly harder though, because of the minus, because of the 4. It's a lot longer for sure. You have to be able to do these. What I actually see is sometimes, well, I mean, a lot of students just have trouble with them. They are hard. There's a lot of steps to them. However, what I see sometimes is that some students can get all the way to here, which means they've done all the hard part. And then I see really weird stuff. Like they start forgetting what they're supposed to be doing. And they add up, I'll see things, I don't know, I'll see weird things. Like I'll see them add up all of this together. So they'll do like 9 and 30 and 25 and 8 and 4 and 4 or something. They'll do it like they'll put it all together and write a to the power of 6. Like I don't know what's going on there. So please, at the very end, please remember that what you're doing, you're supposed to be doing like terms. Okay, that the only way you can add up, and I don't know, I just think it's because people are really focused on the multiplying out, that they forget about like terms. But so it's really important that when you're doing something like this, that you take your time, and at the very end, you remember that you need to do your like terms. Okay, let's just do one more. I know it's kind of long, okay, but I really suggest writing it down. Some of you are not writing anything down, and you're not going to know how to do the problems that I give you. Okay, guys. Okay. So this one, again, is probably even harder than the other two because there is a 3-term multiplication, and there's 2 variables. Okay. Okay, Michaela and Winston. Okay, guys, you need to be quiet. Okay, you really should be writing it down, like I said. Okay, I'm not going to force you because you're in grade 10. You can make your own choices. But sometimes your choices might lead to you failing a unit. Okay, so here, the first thing I have to remember is when I see that squared, what I actually do is if I see squared written down in a question, I will write kind of over top of the question. Like if this was a worksheet, I would kind of write over top of where it says squared, and I would write 3x plus y. That just reminds me right away that squared, all it means is that I'm multiplying by itself. I like right away write kind of over, it's a 3, yeah. And it's just over top of that too, so it looks weird. Okay, so right away I have 2 expressions that I need to multiply. So I have 3x times 2x, that makes 6x squared. I have 3x times negative 4, that makes negative 12x. I have y times 2x, that makes plus 2xy. I have y times negative 4, that makes negative 4y. I have negative 1 times 2x, that's negative 2x. And you can see I'm running out of room here. Negative 1 and negative 4 makes positive 4. Okay, so that is long. Okay, so that's just the first one. Okay, so I need to also do the second one here. So I have minus, and it's extremely important to keep your brackets here. This is when the brackets matter the most. Okay, so it's 3x times 3x is 9x squared. 3x times y is 3xy. Y times 3x is also 3xy. And y times y is y squared. What I'd hope you notice is that when I'm doing this, I always go in the order xy. It doesn't matter what letter multiplies first. I don't mind it if people write yx. I'm not going to mark it wrong, but it is easier if you always put xy. It's not an OCD thing. It just makes it easier. You look at the different xy's and it's obvious they go together. Yeah, exactly. Yeah, that's exactly it. So if you put yx, what happens is students get confused and they're not sure if they're like terms. They ask me, is xy and yx like terms? And it's fair because they don't look the same really. So if you always go alphabetical, then the like terms are more obvious. I really don't like to see, I don't care about yx so much. If students want to do that, fine. What I don't like to see is things like y2x. Like putting them out of, like putting the number in between two letters or putting the number at the end of the letters. That shouldn't happen. The coefficient should always be out front. Okay, so now we have this. Now what's really important, why I said this bracket is so important here, is because this subtraction sign, I would say the number one mistake with this stuff is that students just think that minus means that it's -9 and everything else is still positive. But what actually happens is that minus sign applies to everything inside the brackets. So you should take a minute and actually write it down, because students don't write it down and then they get questions wrong. If you write it down, you just take everything out of the brackets at the front, because the brackets don't matter. And you could start to simplify here a little bit actually. Like I could start to put things like the 12x and the -2x together. That's the only thing I can simplify here. But that's just makes it a little bit shorter. If that's 6x squared minus 14x plus 2xy minus 4y plus 4. Okay, and then that, just like Winston said, it's that subtraction sign goes to everything, so it's minus 9x squared minus 3xy minus 3xy minus y squared.
Well, we did this last year.
Yeah, you did do it last year in grade 9, and I'm sure it caused problems then as well. I'm sure if I spoke to your teachers, I would hear that mistakes were made. Okay, so it is part of grade 9. It's in the polynomials unit, but it's something that really kind of confuses students. So it's because you're subtracting the whole bracket. You're subtracting everything in there, so that minus needs to go to all of it. Cynthia, you have a question?
Yeah,
You could have, yes. You could have just right away said, oh, that's going to be 6, because it's 3 and 3 makes 6, so it's going to be -6. And you could do that right away if you wanted to. Okay, and it would be good because it would kind of shorten things up a little bit. Now we should really do our like terms. So there's lots of like terms here. So I would do it slowly and make sure I've done it correctly. I have 6x squared and -9x squared. They go together. So that's how many x squareds? -3x squared. Great. Okay, I have, and it doesn't technically matter. When you have this kind of stuff, the order gets really confusing. So there's just -14x. There's nothing that goes with it. So I'll just go -14x. There's nothing in that. Oh, there's 2. There is some stuff that goes with it. So I have 2xy, and I have my 2 3's. So that's 2 minus 3, which would make how many? -4. So it's -4xy. Then I have -4y, and that's the only one like that, so it's just -4y. I have +4, that's the only one like that, so it's just +4. And my last but not least is my y squared, and again it's the only one. So that one's ugly at the end. It does not simplify nicely. That is one where I would kind of expect to see students doing weird stuff, because I would think they look at it and they're like, that can't be right. And they like start adding things together, like they'll add the y with the xy or something. So just, it's okay. Sometimes these are not going to be pretty. Okay? We're just multiplying them out and putting them together. Okay?
Are you going to do like a worksheet?
Yeah, we're going to do a worksheet on this. So, that down. Okay? But I'm not going to do an entire problem, but I want to just say, if you are given something with a cubic, because you will be on the worksheet, and I actually feel like there's, I can't remember if it's on the test or on the assignment, but there's one on the one on one or the other. So if you have something like 3x minus 1 cubed, right, that means 3x minus 1 times 3x minus 1 times 3x minus 1. And I'm not going to do this entire question because it's long, but if you were doing it, the way you would do it is you'd multiply out just this, you would get an answer, you'd put the answer in brackets,
Same thing as the other side too.
and you'd multiply it by 3x minus 1. Okay? So it's a long process. It's not just cube both things. That's similar to the squaring both things phenomena that happens. You have to multiply out. So if you see cubed, it actually means quite a long question. if you see something, once students get to grade 12, they sometimes have to do 1s to the power 4 or to the power 5, okay, and it's just in a question, and it becomes very long, and it makes them sad. Okay, so it becomes quite a long situation. I'm going to hand this out. This is just 5 of these because they are long. I know they're long. If you feel like this is not enough space, which some of you may feel, use a piece of loose leaf.
If I had a TA to write a word, I'm not even kidding. I get 100s in every class.
I feel like Whiteboard is
You're
really
getting
good.
your life to do that.
No, but just for me, everybody's smart.
Yeah, we have to pay somebody $60,000 a year just to write all your stuff down. What?
Could I pay them?
This little that doesn't want to write down, you want to?
It's not worth it, unfortunately.
Is it really not that worth it?
You live in Yale, you'll be broke by the end of the year.
Yeah, but I'll be broke with 100 A's. A on every A on my exam. A. Like, just smell it. Just keep smelling good. It's a big. No, don't smell
Thanks,
it.
Mark. Man, I'll mark them tonight.
No.
Hey guys, I will have your quiz for you tonight. Before I give you the worksheet, I'm not going to do a whole problem. Oh, sorry.